Okay, so the one here on the left is the screw. It's a GRK R4 number 9 by 2 inch. Sorry, this is the critical zone pattern.
Yep. So on the right is the... Yeah, so on the right is typical. There's some zones that need a little bit more fastening. And I think an easy way to kind of visualize this is if you take a 12-foot 2x6 and put it up on 2 blocks and stand on it, you get a certain deflection. If you put 2 2x6s on top of each other, you get half the deflection. If you nail those together, you're going to get about 1/4 or 1/8 of the deflection. So it all depends on the transfer of forces between those plies, and that's what we're trying to achieve here. So different areas where these plies interface need a certain amount of force to get across. We have 2 fasteners that are doing 2 things. The first thing is to pull the panels together, so a screw is much better. So to pull the panels together and get that adhesive to squish is the first roll. What we found on the early houses is we just rolled with that. We went with screws everywhere. It ends up with a lot of screwing. I mean, you think screwing off a deck is fun. It's more fun to do these 2 panels together all the way around the house.
It was really fun.
It was really good.
That's something mindless to do.
Yeah, but at a certain point, once you've got those panels pulled together, really all you need is a dowel, a wire across that line, across that interface. And so we can use, this is just a typical ring shank gun nail that gets the same that a screw would. After you've gotten the plies together, all you need is something across that zone, and obviously the gun nail will go a lot faster. So the circles you see there are what you need to kind of pull the 2 plies together with a screw. That GRK R4 is only a 2-inch screw, so this isn't something massive, but it's enough to pull those 2 together and not poke through the other side. And then after that, you infill with the X's are just a gun nail. So what you see there is a 2-foot by 2-foot area and what you need to fasten within that.
And what you'll find as you start playing with the material and the carpenters are moving stuff around, this is one of the places where the 2-inch screw, when you're trying to close a 1/4 inch or a 1/2 inch gap between the panels, the 2-inch screw doesn't have enough shank to get to the other one. That's when you pull out the 4-inch clamp that you have in your pocket. It pulls them together, and you can just leave it in, tack it all off, and then back it out later, right? So here you'll notice
Steve, you have a question.
hang on one second. Here you'll notice this is the 1/4 inch bead adhesive in between the 12-inch spacing for the screws. What's the question? Yeah, Les.
It says on either side of the window, on each side of the window.
Yeah.
How close are you to the edge of the window? To the edge of
With the bead?
with the screws and where does this layout start?
Yeah, so the layout is somewhat arbitrary, but you want to bring that layout to opening. So let's say you're coming across a wall, right? And you've got a window opening here, and basically this is your layout.
You got a darker marker?
I don't. This marker sucks. How about that? Does it work?
Yeah.
All right. So this will more than likely be some scenario in which you have, in which case you're just going to come through here and jump around that window. Now, if you put a bead, seeing that picture that we saw with the spread, a 1/4 inch bead will spread out 2 inches to either way, right? So that'll give you an idea that if you put that 1/4 inch bead in 2 to 2.5 inches in from an opening, and you put your screws right on top of that, right? That's a pretty good rule of thumb to get there. And you'll see too when you cut out your windows, and I'll show you some pictures of the windows. It's sort of the first autopsy you do of your walls. When you cut out the window opening, you see what did the windows or did the panels come together, right? And sometimes you have to do some moving there.
This is a good example of where the monolithic structure is a little bit different than a stud wall, but you can kind of treat this fastening pattern like you would stud walls. One of the engineering rules of thumb for how many kings do I need on the side of an opening when you're framing is how many did you interrupt and split those up and put them on each side. So that's the kind of wind, when studs are acting in wind to stiffen a wall, whatever you got rid of with that opening, slide them to the sides and gang them up. And that's kind of the same here. The amount of fastening you need is however much you interrupt with the opening size. to be frank, the 3-foot openings really don't hurt these walls. They're not as critical. Where we're trying to expand is the 6 foot. It gets to where we care a little bit, and we're trying to stretch it beyond that so that we don't have a 6-foot limitation for this type of build. But in general, it's kind of go right around the openings. A lot of these openings are too small.
Once again, some of these pictures are from previous iterations of design, but when we're setting out the trusses, the one structural piece that we have on the cedar is the stairwell opening. And basically the stairwell opening is sandwiched on either side by a long truss, and then we have an LVL beam that carries in between them that carries a set of short trusses. Now on this picture, we're seeing an old layout. The way that the layout runs today is that you'll have the two longer full-length trusses will sit like this. And then what we've done is we want to order and have this LVL span between the two. But this is simply an installation shortcut. Because what this allows us to do is to not have to worry about building up temp walls underneath and supporting a beam out in the middle of nowhere. We can just hang it off of here, and then we can run our shorts back. Okay, and then the engineering has a location underneath that, a particular location of where we want to put the posts. Okay, so that the beam actually is independently sitting on top of posts, carrying these loads. But what we're trying to do is spread this out a little bit over to this truss so that we don't have a really large deflection on this full-length truss there, and then on a shorter truss next to a post, very little deflection, right? Because you'll step on it here, and then 2 feet later you'll have a different deflection into that system. So we're trying to tie those together a little bit so that we bring that deflection a little bit more in line, and then you don't have sort of that sag that can occur in houses. Between, when you're walking across the floor, you get one set of trusses going this way and another set turning this way, and right at that beam, it's like the house climbs up a little bit. Another shot of that. So that's one of the structural components that we'll put into place. This will allow us to set all the trusses. Then at that point, we can run down and we can put in the 2 posts. They can be temporary posts just to sort of provide structure. And then the other thing that we're going to do is we're going to put a temporary brace over that opening, because as we set the first floor subfloor panels across there, we're running them wild over that stairway opening so that we aren't having a hole that we're going to fall down in. We have a working surface that's continuous around the whole thing, and we'll come back and cut that out later. But this is all happening, like I said, on the first day prior to panels showing up, which would be the following day. Okay. Any questions on that?
You're not using the crane to set
Those trusses?
Yeah.
No. Yeah, those very easily can just be walked out.
Yeah.
Generally what we have found when we got to our most optimized time duration on the build, the carpenters just sent 2 carpenters out that first day, and those 2 carpenters in an 8-hour day got all the plates set, got all the trusses laid out, and got the LVL and the posts and everything ready. So it was just 16 labor hours for that maneuver to occur.
Your foundation wall is, what did you go, 9 foot with the top cord bearing?
Yeah, with the top cord bearing, we did a 9-foot wall, or 9 foot, what was it, 99?
9-foot pour.
9-foot
top
pour.
cord bearing.
Yeah. But we also had this, I don't know if you can see the windows. We did one where we framed out, I don't know if I have it in here. No. We had the window completely cut out, which we had to frame over a header over the window, and then we got the concrete guy, a different concrete guy, because we were like, we need you to pour that as a beam, like instead of us framing that out, kind of defeats the purpose. But now with an 8-foot wall, because we're sitting up taller, then we don't have that issue at the window. Okay, so then the last thing that needs to happen on day 1 is this is the short wall rim, basically, is the best term for it. So on the front and back of cedar, as that wall terminates, the last truss is here, we have to build out basically a ladder and tie that back with bracing. Now in this case, what you see here is we have a little triangle that we just basically set up a jig and just cut a bunch of these, which is just a piece of the OSB. And this has, you know, a notch for the 2x4 here and a notch there. And it allows just to set them in place, tack them up. I actually got a video of us attempting this.
Did you pre-cut out some windows? Get that material?
So that's the hitch in that, but we're not doing that anymore. So we had a bunch of OSB that we were able to pre-cut that, but in theory, you're not going to have that on site. And so what we drew on this last one is just a 2x4. Basically at an angle. So we're going to build, because we also have a 20-inch tall rim that we're going to build, we're just going to build a 2x4 top rim with shorts all the way across tacked into the plate. So it basically creates a wall. And then on the bottom cord of the trusses we'll run like a runner all the way across, tying into the plate of the wall. And then we can do an angle from that last truss down to the, so it'd be essentially what you would do on a normal floor system that you would frame. Does that make sense? So this little detail that you're seeing here, you wouldn't necessarily do out of OSB. If you had them, it's doable and it's using up scrap and waste. But if you don't have them on site, which is a possibility, then you're just going to build it out of lineal and just frame it like you normally do.
I would just add that this is one of the oft missed details in home construction that we get callbacks on. When you have a foundation wall that's subject to earth pressure, it's leaning on both your basement slab as well as at the top it's leaning on your floor system. And if you are parallel to your trusses, you have nothing to lean on until you block up to the what we call the floor diaphragm or the subfloor. It somehow needs to lean on the floor system, and when you have that gap, we get almost weekly calls of cracked foundation walls because this isn't done.
Does that make sense? Okay. Okay, so that concludes sort of day one of first floor framing and prep. Day two is when the crane shows up, and I'm going to play a video of.
We should maybe just the caveat that the maple design day one is a little bit different just because of the.
Yeah, we're gonna stay out of the maple is so far out of this. We're gonna stay out of that for now. What? Oh. Hit the lights. Let's see here. Get down.
Steve,
Yeah.
I know you want to concentrate on the cedar, but we're going to be doing the maple here, so if you could touch on that just a little bit.
So, yep. The
Can we
maple.